Hello students, I Hitesh Prajapati, Assistant Professor in Mechanical Engineering Department of Aditya Rocky Institute of Technology. I welcome you all in my video lecture of the IC engine subject. So in this video lecture, we will discuss about this introduction to heat engine, difference between IC engine and EC engine. Then after we will cover about this classification of internal combustion engine, the basic component, its function of IC engine, engine terminology, thermodynamic analysis. Then after we will go for the working of the four-stroke petrol and diesel engine with actual and theoretical PV diagram, and finally we will plot this wall timing diagram for this both the engine. So heat engine. So students, as you study in the lower standard the first law of the thermodynamics, and according to the first law of thermodynamics, it states that the one form of the energy can be converted into the another form of the energy. So heat engine is a device which converts the heat energy into a mechanical energy, and the heat is produced by the combustion of the fuel. So according to the place where the combustion of the fuel will take place, there may be two type of the heat engine. First, external combustion engine, it's said to be a EC engine, and secondly we have internal combustion engine, it means IC engine. So in external combustion engine, the fuel of the combustion will take place outside of the engine cylinder. Example of it, steam engine. So what happens in the steam engine? So steam is produced outside of the engine cylinder, and then the heat energy of the steam energy will be converted into a mechanical energy. So this is what about this external combustion engine, it means IC engine. And in the IC engine, the combustion of the fuel will take place inside the engine cylinder. Example of it, four-stroke petrol and diesel engine, as well as two-stroke petrol. And if we look at this, so in this slide, if we will look at this detailed comparison between the EC and IC engine. So as I said in previous slide, the EC engine is nothing but the engine in which the combustion of the fuel takes place outside of the engine cylinder, and in IC engine, the combustion of the fuel will take place inside the engine cylinder. The example of the EC engine is nothing but the steam engine, where the example of the IC engine is two-stroke petrol and diesel engine, four-stroke petrol and diesel engine. So in steam engine, we are generally use the working fluid as a steam, where in IC engine we are generally using the working fluid as a mixture of fuel and air. So in AC engine we are used to working fluid as a steam, so we have to generate this steam. So this steam is generated with help of the boiler or any other steam generator device. So if we look at the size of the boiler and steam generator, so but obviously it has the large size, where the IC engine is very compact size. If we talk about this efficiency, so IC engine is very less efficient compared to IC engine. So also the cost involving the initial, so initial cost of the IC engine is very less compared to EC. So now students, we will try to classify the IC engine, and for the classification of the IC engine we have to consider the certain criteria like working fuel used, thermodynamic cycle, number of stroke per cycle, method of ignition, cooling method, speed of IC engine, number of cylinder, and lastly position or you can say arrangement of the cylinder. So first classification on the basis of the working fuel is used, and according to that we have petrol engine, diesel engine and biofuel engine. In petrol engine we use petrol as a working fluid. In diesel engine the diesel is used as a working fuel, and in biofuel engine we are using the mixture of two or more fuel as a working fuel. Second classification according to thermodynamic cycle, and according to that we have Otto cycle engine, diesel cycle engine and dual cycle engine. So petrol engine is works on the basis on the Otto cycle engine. So example of the Otto cycle engine is petrol engine, and diesel engine is works on the basis of diesel cycle engine, and so the diesel engine is the example of the diesel cycle engine, and mixed cycle engine is works on the dual cycle. Third classification according to number of stroke per cycle, and according to that we have the four stroke engine and two stroke engine. Now students, the question is arise here, what is four-stroke engine and two-stroke engine. So students, the four-stroke engine, the piston has to travel the four times the stroke length during its one working cycle. So it is known as a four-stroke engine. And the two-stroke engine, the piston has to travel the two times the stroke length during its one working cycle. In the both the cases, we have the four-stroke petrol and diesel engine, and in two-stroke we have the also petrol and diesel engine. Fourth classification according to method of ignition. So according to that we have the SI engine and CI engine. SI means spark ignition engine and CI means compression ignition engine. So in SI engine, the combustion of the fuel takes place with help of the spark plug and it is known as a SI engine. So in petrol engine, the example of the SI engine, and in the CI engine, we are start the combustion or ignite the mixer with help of the compressed air. So it is known as a compression ignition engine, and in the diesel engine is the example of the compression ignition engine. Fifth classification according to method of cooling. So as we know that during the working of the IC engine, there are large amount of the heat will be generated by the combustion of the fuel. The engine has to be cooled. So we are using the two method for the cooling. First is air cool and second is water cool. So generally low capacity engine cool with help of the air. So that kind of engine is known as air cooled engine, and high capacity engine can be cooled by this water. So those engine is known as a water cooled engine. Fifth classification according to the speed of engine, and according to that we have the low speed engine, medium speed engine and high speed engine. Seventh classification according to number of cylinder. So if your power requirement is more, then we can use the only single cylinder engine, and if we are require the more power, so at the same time we are using the two or more cylinder engine. So according to number of cylinder, we have the two engine, single cylinder engine and multi-cylinder engine. If your cylinder is more than two, then arrangement come into the picture. So last classification according to position, or you can say arrangement of the cylinder. So arrangement can be of cylinder like inline engine, V engine, radial engine, opposed cylinder engine, opposed piston cylinder. Now students, we will cover in this slide the basic component of the IC engine. So as you can see in this slide, it is a figure of single cylinder IC engine. So at the center we have the cylinder block, or you can say cylinder. Inside the cylinder we have the piston, which have the reciprocatory motion, which will reciprocate up and down. The uppermost part of the cylinder is known as the cylinder head, and the cylinder head is provided the space for this inlet valve, exhaust valve and spark plug or fuel injector. Through the inlet valve, the mixture of fuel and air will take place into the cylinder, and through the exhaust valve, the exhaust gases or burn gases sweeping out to the atmosphere. The piston, as I told you, the piston have the reciprocatory motion, and we have to convert finally into the rotary motion. And for that purpose, we are using this connecting rod. So connecting rod is a rod which connect the piston and camshaft. The connecting rod has the two ends, smaller end and bigger end. The smaller end of the connecting rod is connected to a piston through the gudgeon pin, or you can say piston pin, while the bigger end is connected to a crankshaft. Students, as you can see, the surrounded space is provided to the cylinder for the cooling purpose. Lower end of the cylinder is known as a crankcase. Now, this is the picture of the single cylinder engine, and next slide you can see the multi-cylinder AC engine. So in previous engine we have the single cylinder, and now inside the multi-cylinder engine, it means it has the more than two or more cylinder. So almost all the part of this engine will be same. So now students, in this slide we will cover about the different component of IC engine with its function. The first part is cylinder, and it is the most important part of the cylinder AC engine, where the combustion of this fuel is taking place and the power is produced inside the engine. Second part, we have the piston. The piston is a reciprocatory device which is reciprocate inside the cylinder. Third is cylinder head. The top part of the cylinder is known as a cylinder head, and it is provided the space for the inlet valve, exhaust valve, spark plug or fuel injector. Third, the piston ring. The top of the piston we are providing the certain rings to prevent the gas leakage. Fourth portion is piston or gudgeon pin. As I said in previous slide, the connecting rod is connected through a piston via gudgeon pin, or you can say piston pin. Next is crank and crankshaft. The crank is connected the bigger end of connecting rod by pin joint. The crankshaft rotate about the axis rotation, so that's why the crank connecting rod can oscillate. Now students, at the top of the cylinder we have the inlet and exhaust valve. So as I told earlier as well, through the inlet valve the fuel of mixer is taking inside, and through the exhaust valve the all the burn gases and exhaust gassing to sweeping out to the atmosphere. Next is flywheel. The flywheel is used for the two purpose. So as we know that during the working of IC engine, it store the power produced, I mean energy, and second, it minimize the vibration. Next portion is crankcase. So it served as a enclosure of the crankshaft and as a use some for the lubrication purpose. Next portion is carburetor, and it is usually generally used in petrol engine. The carburetor, the function is it mixes the petrol and air in a proper proportion so that ignition can be occurred. Next portion is fuel injector and fuel pump, and these parts are usually generally used in diesel engine only. The fuel injector is atomize the diesel inside the engine cylinder. Atomize means ki the larger droplet of the fuel is converted to smaller droplet so that the combustion can be easily start. And the fuel pump is develop the pressure so that why the pressurized fuel can be injected. And lastly we have the spark plug, and which is used for the to start the combustion in the petrol engine. Now engine terminology. There are the certain terminology which are using the, or you can heard about this terminology. First is bore. The bore is nothing but the inner diameter of the cylinder, and it is indicated by the capital D. Second, stroke. It is the linear distance traveled by the piston from one end to the another end of the cylinder is known as a stroke length, and it is indicated by capital L. Third, dead center. So suppose this is the vertical engine. So in vertical engine we have the two dead centers, TDC and BDC. TDC means top dead center and BDC means bottom dead center. So in vertical engine, the topmost position of the piston is called as a top. TDC means top dead center, and bottommost position is known as a BDC, or you can say bottom dead center. Fourth is clearance volume. So there is always clearance between the cylinder head and TDC, and that clearance volume, this volume is known as a clearance volume. Fifth one is stroke length, or you can say swept volume. So it is the linear distance traveled by the piston from one end to the another end of the cylinder is known as a stroke volume, or you can say swept volume. As I said to you, L is nothing but the stroke length. Capital D is nothing but the bore or inner diameter of the cylinder. So suppose we need to find out this stroke volume. So pi by 4 T square into L. Now, from that above terminology, we can define the compression ratio and very most important in the IC engine. So, compression ratio is nothing but this, it is the ratio to the total cylinder volume to the clearance volume. And as we know that this total cylinder volume is nothing but this, it is the summation of the swept volume and clearance volume. So, mathematically you can see the R means clearance ratio. Now next one is piston speed, and it is the speed of the piston at which supposed to travel from TDC to BDC or BDC to TDC. So it is the average speed of the piston and it is equal to the twice Ln. So N is nothing but the speed of the crankshaft in revolution per second, and L is nothing but the stroke length of the piston. So piston speed mathematically we can write Vp is equal to twice Ln, unit will be meter per second. Next is some terminology or some definition which are used to for the thermodynamic analysis. First is indicated power, and it is the power produced inside the cylinder by combustion of the fuel take place. Mathematically we can write IP is equal to PM LAN by 60 into 1000, so unit must be kilowatt hour. So PM is nothing but the mean effective pressure, as we know that the piston is from traveling from TDC to BDC to TDC continuously. So at the each and every point of the piston, the cylinder pressure will be vary. So PM is nothing but the average pressure during from TDC to BDC or BDC to TDC. L is nothing but this stroke length. A is nothing but this cross section area of the cylinder. N is crankshaft revolution in RPM. Next is brake power, and as we know that the whatever the produced indicated power inside the cylinder will be utilized to forcing down the piston, as well as some power loss for the cooling and many other purposes. So available power is very much less compared to produced power, and it is the actual power available at the crankshaft. Mathematically, we can write Bp is equal to 2 pi Nt upon 16 to 1000. 2 pi is again constant, N is crankshaft revolution in RPM, T is nothing but the torque produced by this crankshaft, and torque is equal to force into radius. From above two terminology, we can define the very most important term mechanical efficiency, and it is the ratio of brake power to indicated power. Now we will define the thermal efficiency, and simply thermal efficiency is nothing but the how much power produced from the heat supply. Suppose here in the case of the engine, there are two type of the power developed by the engine. First is known as indicated power, and secondly we want to have the brake power. And the heat supply to this engine can be calculated by the whatever the mass of fuel is supplied to the engine multiplied by the calorific value of the particular fuel. So indicated power is nothing but this ratio of indicated power to heat supply, means MF into CV. Same way we can define the brake thermal efficiency, and it is the ratio of brake power to MF into CV, means heat supply. As you can see in the figure, the total heat supply or fuel energy supply to this engine cylinder somewhat lost in exhaust coolant or radiant, so that's why whatever the heat supply is more compared to indicated power. After indicated power, somewhat power is used to against the friction power, different losses, and finally the somewhat less power available at the crankshaft, as you can see pictorially in this figure. Now, again, one more important terminology, which is volumetric efficiency, indicated by eta V. So, as we know that the power produced by the engine is directly depend upon the how much charge or mixture of air and fuel getting inside this cylinder. If suppose more charge getting inside the cylinder, so more burning will happen, more amount of heat and energy will be generated, and more power will be developed. So here want to define volumetric efficiency. So volumetric efficiency is nothing but the mass of actual charge getting inside the cylinder to the stroke volume. As we know that the large amount of heat energy will be generated, and that's why the engine parts will get heated like cylinder head, inlet valve, exhaust valve. So during the induction of the charge will be getting the expanded. I mean to say its specific volume will be increased. So it requires the more space, and so that's why it get less inducted into the cylinder. So definitely the less will be charged will be inducted. Then the less combustion and less power will be developed. So volumetric efficiency is nothing but the ratio of mass of charge actually taken inside the cylinder to the stroke volume. Definitely stroke volume is more compared to uh, charge charge getting inside the cylinder. Next one is relative efficiency, or you can say the efficiency ratio. So it is the ratio of the thermal efficiency to the air standard efficiency. So when we compare the any efficiency performance of the engine, so we are comparing with the air standard efficiency. So here the efficiency ratio is nothing but the comparison between the thermal efficiency to the air standard efficiency. So air standard efficiency is nothing but this efficiency of the engine, as we consider the air as a working fluid and which giving the highest efficiency. Next one is specific fuel consumption, or you can say brake specific fuel consumption. So it is the ratio of how much fuel is required to produce the unit kilowatt of power. So as you can see in the slide, the SFC is nothing but the fuel used per hour to the power developed by the engine. Mathematically, we can write MF upon P, and its unit will be kg per kilowatt hour. So the last terminology is air fuel ratio. Students, as we know that the combustion of the any fuel which require the air, or you can say oxygen, right? So in the engine we are injected this air simultaneously with the fuel. So air fuel ratio can be defined as the mass of air to the mass of fuel. Ma is nothing but the mass of air, and Mf is nothing but the mass of fuel. Students, in the next lecture we will study about the how the four-stroke engine is works, how can we plot the PV diagram as well as valve timing diagram, theoretically and actually diagram, what the difference and why the differences occur. So we will see in the next lecture. Thank you.